Let's take a look at the final example of separable differential equations at the end of page 606. So this time we've got the dy dx is equal to y minus 1 over x squared, and f of 2 is equal to 0. So once again, we're going to separate our equations, getting all of the y's on one side of the equation, all of the x's on the other. So I need to divide both sides by y minus 1 to get the y minus 1 over to this side, and I need to multiply both sides by dx to get everything over to the x's over to the right-hand side. Once again, when I do that, that's going to get me to 1 over y minus 1 dy is equal to 1 over x squared dx. All right, so now to find the antiderivative of both sides of this equation, I'm going to do the same trick I did over here. So this is going to be just 1 over u du, so it's going to be the natural logarithm of the absolute value of u. And so that's going to turn out to be the natural logarithm of the absolute value of y minus 1. Over here, I'm not going to do the same thing. Why not? Because 1 over x squared is x to the negative 2 dx, and I can just use the power rule for this. This is an example of the natural logarithm. Natural logarithm is only when I've got 1 over u, and this is 1 over a variable squared. So the antiderivative of x to the negative 2 power, we're just going to use our standard antiderivative ideas. So it's going to be x to the negative 1, and then I divide the coefficient by negative 1, which is going to give me a negative over there. All right, or I can write that as negative 1 over x. And once again, I'm going to toss in a constant term. So now that I've got this, I'm going to substitute in 2 for x and 0 for y. So over here, I've got the natural logarithm of 0 minus 1, which is negative 1. The absolute value of negative 1 is 1. And that's equal to negative 1/2 plus c. So what is the natural logarithm of 1? Remember, natural logarithms look kind of like this. That's kind of the rough idea of how that function looks. And so for any logarithmic function, it's equal to 0 when x is equal to 1. So the natural logarithm of 1 is equal to 0. Negative 1/2 plus c. So I just add 1/2 to both sides, and I get that c is equal to 1/2. So in this case, my function is going to be the natural logarithm of y minus 1 is equal to negative 1 over x plus 1/2. Okay, or I could write that as 1/2 minus 1 over x, I suppose. Maybe that looks a little bit better. And once again, this is an expression in terms of x and y. I'm sorry, it's an equation, not an expression, because it's got an equal sign in it. And it satisfies both of these conditions. So really, I'm done with the problem right now. I could find exponents kind of like I did here. I'm not sure it would make this any prettier, though, because that negative 1/2 is not going to become as pretty as this natural logarithm of 2 just becoming a 2. It's going to be an extra term of e in there still. So this is probably, I mean, A, it's fine, and B, doing the work is not going to make this any prettier. So why don't we just leave it like that? All right, so this is the basic idea behind solving differential equations. So you're finding antiderivatives. In this case, you're doing separation of variables in order to pull those things apart. As I've said before, if you take a DiffyQs class in college, you're going to learn a whole lot more techniques for solving a greater range of problems and problems that have a real significance in engineering and physics is where you're going to be focusing your time probably in a class like that. You're also going to learn numerical methods for solving those with computers in cases where a natural solution is either hard to find or impossible to find. But this is all of the solving of differential equations that we're going to tackle in AP Calculus. All right, so take a stab at the homework there. And in the next set of lessons, we're going to talk about differential equations in a slightly different way and see how we can draw the graphs of differential equations given conditions like this. So it's kind of fun because you get to draw some pictures.